There, I'm Jake. I'm going to tell you a bit more about the Bunsen air system, which basically this is the Bunsen air. It consists of a small unit which is a heat pump, and it consists of two panels which are mounted externally, and they're what gather all the energy that we're going to use, the free energy from outside. Okay, so this unit is basically a little heat pump, and to install this we basically create two loops. We always install this as close to the hot water cylinder as possible for reasons I'll explain in a moment. But all we're going to do with this is we're going to create two loops. One is a water loop and the other one will be a refrigerant loop going out to the panels and back. And they're separate. They only join in the middle where there's a heat exchanger. Other than that, they're completely separate. Okay. So to install this unit, basically what we're doing, if we're going back to an existing cylinder, all we're putting in is this length of pipe here and this length of pipe here. All of that would already be in place in any normal standard system. So what's going to happen is we're going to drop an extra pipe down into the cylinder, so we're pulling the water from the bottom, not the top. It's colder at the bottom, so we'll heat that. So all that's going to happen when it's running is the water's going to come up from the bottom of the tank, of the cylinder. It's going to come through here into the unit where it's going to take some heat out of the refrigerant, and then it's going to flow back down and into the cylinder. So we keep this distance as short as possible because we don't want the water out of the cylinder where it's nice and insulated for any longer than it needs to be. All these pipes will be insulated once we finish the installation, but just for now we're just showing you how they all go together. So we create that very simple water loop, and the water is driven round by a very small pump, which is a completely standard piece of equipment. So I'll take the lid off this unit and you can actually have a look at what's going on here. So as I say, the water's coming in, just comes in through a pipe. That's actually the heat exchanger where the heat gets transferred, and then it's going to come back out. But in order to harvest all this free energy, we use refrigerant. So what's going to happen is we're going to use these white pipes to run to the panels. Now the panels are mounted generally a maximum of about 10 metres away from the unit. Closer the better, but we can go up to 10 metres away. Okay. What's going to happen is the refrigerant is going to come out here as a cold liquid. Now this refrigerant boils at minus 26 degrees. So it's going to come out of here as a very cold liquid. By the time it's flowed around the panels, it's going to absorb so much energy from the atmosphere, from the temperature, from wind, from all different types of sources, that liquid is going to heat up and it's going to expand and change into a gas, what's called a superheated vapour. Then it's going to come back into the unit through a fatter, thicker pipe. It basically gets squashed back down by a compressor, which happens to be that piece of kit there, giving off a whole load of heat. And it gets squashed back down to a cold liquid ready to flow back out. Now all that heat needs to go somewhere, so we simply transfer it into the water. So the water's circling round, it's picking up all the energy and taking it away. The refrigerant is coming back in warmer, getting squashed, giving a load of heat off, which we happily accept and put into the water, and then out it goes as a cold refrigerant. So I'm going to turn this unit on and we'll go out to the panels and I'll show you a little bit about how we get all that free energy when we mount the panels. So we're outside, and our panels are just mounted the other side of the wall where we were inside. It's probably about a 5 metre run in total for the pipe work. Basically what we have is just two panels which are mounted outside. Now the refrigerant is going to come out this pipe here and flow out around the panels. If you put your ear to it, you can hear it. It's flowing. Okay, so it comes out as a liquid. Everything transfers heat onto these panels. So the wind blowing across them, fantastic at generating heat. Just the ambient air temperature, again, that's a great way of transferring heat. Rain is brilliant. Snow contributes. And yeah, direct sunlight, but it's not about direct sunlight, this product. It's really important that there's no sun out today. This is working as well as it ever will work. Okay, sunlight will add a bit of an extra dimension, but we never even include sunlight in any of our testing we ever do. So this doesn't have to be mounted in direct sunlight. It's really important you understand that. Wind is probably the most critical factor because we've always got wind in this country. Okay, so these panels are both mounted in landscape like that. The panels can be mounted in portrait if you want, or actually the mounting brackets here have a hole halfway back, so they can be sandwiched together and again be either in landscape or portrait. So space is tight, we can do that. Bit better to have them spread out, but there are options if you want to just sandwich one behind the other. But it's really important to understand that this is not about light, it's about energy and exposing it. So that's the reason this works just as well at night as it does on a day like this. It's a day or night product. It's 24 hours a day, 365 days of the year. And that's really important to remember when you're recommending this product. Windy areas are probably the best because we've got wind all the time. We don't get that much sunlight. And often when we're using the heating of hot water, it's not even in the sunlight periods anyway. So really important to understand that. But these are very durable, tough panels. Okay, it's not a complicated technology. We'll go back inside. Okay, so we're back inside. Like I said, the panels are outside on the outside wall there. Now we've seen it. So now we understand what's going on. Going out cold, absorbing all that free energy and coming back in. So, how does it know when to work and when not to work? This is a completely automatic system. There's a couple of options we've got for it. We can either set it on fully auto. Fully auto, we set a target temperature of 53 degrees, and then at any point if the temperature drops in that cylinder by 5 degrees, the unit will just kick in, bring it back to temperature, and then go back to standby. So how does it know? Well, we run a cable basically with a very simple little sensor on the end of it. That goes in there, that's called a dry pocket. If we don't have a dry pocket, then basically we'll create a hole in the side of a cylinder and make sure that we've got contact with the inner temperature of the cylinder, so we know exactly what's going on. So that's very simple. But this has got advanced features. Actually, the one on my property, and let me say, I'm on oil, or I was on oil. I put one of these systems on. We're a household of 4, we're big water users. We're up here in Yorkshire. I put this system on in October of last year. I have not used anything else to make my hot water. We've had the freezing cold weather, -6, we've had all of that. This has done 100% of my hot water. This is not a contribution product. This will displace whatever heating system you've got. Leave it in place by all means, but you don't need to use it. This can take over all the heating. It doesn't do a little bit, it does the lot. Okay, back to the temperatures. So on mine, I've actually used some of the advanced features. So what you can do is you can actually choose 3 different times and temperatures of the day. So mine, for example, I only have it at a lower temperature through the night because I don't need buckets loads of hot water, and I have it doing the most of the heating through the day when the weather's warmer and the system is even more efficient. So there's variables like that. Doesn't matter what target temperatures you have, it's still all fully automatic, so you don't need to worry about it. But there are variables that you can have even more efficiency on the system, and they're very simple to program and very simple to do. Once you have programmed it, that's it, you just forget about it. You do nothing. You don't look at it, you don't touch it, you don't need to do anything. You'll just have hot water day and night as long as you need it. So I'll just recap on a couple of points. First and foremost, what this does, it makes your domestic hot water. It's not a central heating product. It'll do all of your domestic hot water if you need it to. Okay? This product works day or night. It has got nothing to do with solar, which is all about light and irradiation coming down from the sky. We don't have that. This is not about that. This harvests energy. It gets it from the wind or the rain, which is why this will work day or night. No problem. Next thing is we can retrofit it, or when we're installing it, you may have a very old cylinder, and we've now done a great deal with Kingspan, so we're getting the best cylinders on the market, and it's a very, very easy opportunity to upgrade a cylinder, put a new one on. They're fantastically efficient, the new cylinders, so you're holding all that heat rather than just bleeding out the side of the old, less efficient cylinders as well. So those are some things to consider. That's the system. Very simple, very easy, very cheap to run. It just runs off a water pump and the compressor unit. This system is running now. So this is the kind of noise volume you've got. There's not a lot. It's not silent, but it's very, very quiet. So any more questions, get in touch with us by all means. Hopefully that's given you a bit more of an insight about the system, what it looks like and how it works.